Hi, I'd like to show you again the acid nomenclature rules, which you actually have seen from Melissa Maribel. Pretty sure that she does this much better than I do. So, this video you do not need to watch. It is completely optional. This video is just for the people who love Glenn. Okay, so acid nomenclature. Acid nomenclature, there are two kinds, as Melissa has said. There's the binary acid, where, well, I mean, there's the acid that has no oxygen in it, so no O. And there's the acid that has oxygen in it, so has O, so yes, O. Now, the no oxygen acids, these are some examples. Not CCN. HCN. Okay, so this is the rule. You write hydro at the top, and then at the end you write acid, and then in the middle, connected to the word hydro, you write the negative ion, except you change its ending to IC. So the negative ion is chloride, but instead of "ide", you put "ic", so it's hydrochloric acid. Okay, that's how you do it. Here, this is an easy example, so let me give you something a little bit harder. So what about this? Now, acids in Chem 10 are all dissolved in water. So if it is an acid, you can assume that it is dissolved in water. I mentioned that because H2S is very often a gas. It doesn't dissolve in water very easily, but it does dissolve in water to a limited extent. But it prefers to be a gas at room temperature. So as a gas, of course, H2S, you would just name it as an ionic compound, where H is the plus ion and S is the minus ion, 2 minus ion. So you would call it hydrogen sulfide gas. It would also be okay to call it dihydrogen sulfide because technically H is a non-metal. But most people call this hydrogen sulfide gas. This is the rotten egg smell that you might notice if you visit a sewage treatment plant. It is also explosive. So they always like to try to collect the H2S gas in charcoal so that they can prevent that they can reduce the likelihood of explosion at the sewage treatment plant. But anyways, as an acid, it is in solution, it is dissolved in water. So as an acid, we name this, we write hydro, we put acid at the end, and then at the beginning, we put the name of this guy, sulfide, and then we put IC at the end. So instead of sulfide, we put you would think it's sulfic, right? But it's sulfuric. Why do we say sulfuric? Historical reasons. It's absurd, yes. It's kind of like the English language. You know how in the English language, like this word is not pronounced the same as this word, right? They are not pronounced the same. And not only that, this word, right? This word is not pronounced the same as this word. This AUGH, AU. Okay, so that's for historical reasons, and it's just the same thing with chemistry. All the weird things are for historical reasons. Like it should be sulfic, but we write sulfuric, historical reasons. Now, what about this HCN? Well, CN is two elements. So you go to your polyatomic ion memorization, and there it is, cyanide. So it's cyanide. Okay, so you would write hydro, write acid, and then cyanide, except we change the ending to IC. Hydrocyanic acid. Okay? So that's with no oxygen. What if there is oxygen? Right, so if there is oxygen, then we use this. Ich, ate, ite, us. Ich, ate, itis. You can remember this as a disease. Tonsillitis, ich, ate, itis, laryngitis, ich, ate, itis, bronchitis, ich, ate, itis, appendicitis, ich, ate, itis. Right? So this is how you use this. Suppose you have an acid like this. Now this is H3PO4. There's 3 H's because H is 1 plus and PO4 is 3 minus. Right? So you need 3 of these to make this a neutral compound. So what is PO4 and how did I know that it is 3 minus? Well, for one thing, I know because there's a 3 here and this is only 1 plus. But I also know because I have memorized, just like Glenn said to, I memorized this. Phosphate is PO4 3 minus, right? So this phosphate, you see it ends with 8. Since it ends with 8, that means I'm going to use the ic ending. So I write acid at the end. I do not write hydro at the beginning. I just name the polyatomic ion here. It's phosphate. But instead of 8, I'm going to put ic. But for historical reasons, it's actually called phosphoric. All right. So notice there's ic there because the polyatomic ion was called what was phosphate. Okay. What about this one? H2SO4. Well, SO4 is a 2- ion, and it is called sulfate, right? So, H2SO4, I'm going to write acid, and sulfate, and using my ic 8 rule here, 8 sulfate. That means the acid is going to end with ic. So, I'm going to say sulfic acid. Actually, no, I'm going to say sulfuric acid. That's for historical reasons. Yeah. I'll write down some examples that are less that have less weird spelling in a moment here. So that was sulfuric acid. Let me give you some ites. So what about this? HNO2. NO2- is nitrite. You see it here? Nitrite. It's 1- nitrite. Right. So nitrite. Nitrite ends with ite. So anything ends with ite takes the OUS ending. So it's not going to be nitrite. It's going to be nitrous. So we call it nitrous acid. You see that? Mm-hmm. Very good. Very good. So that's how you do it. All right. One more that is not that doesn't have the weird spelling here. Let's just pick one. How about carbonic? Carbonate. Yes, carbonate. So H2CO3. That's carbonate. So that's carbonic. Carbon, not carbonate, but carbonic acid. Why? Because carbonate ends with 8, and 8 things go with ic. Right, let's do another us. So, how about phosphorous acid? H3PO3. PO3, 3- is the phosphite ion. Phosphite. So if it's phosphite, then the ending should be OUS. So, you should say, ordinarily we would write phosphus, but for historical reasons we do not write phosphus. The IUPAC have decided that we should write phosphorus acid. Okay, that's how you do it. And thank you.